Yeah.
Okay, so we're going to write the chemical reaction. We've got HCl plus NaOH yields water and a salt. And I want you to notice what kind of arrow I'm using. This is not an equilibrium. Neutralization is a driven reaction. Okay? You have a strong acid and a strong base. They totally react. Okay? It's only weak stuff that doesn't totally react. Okay, so here we're going to do stoichiometry. I know some of you use this formula MAVA. Michaela, this is what you were talking about earlier. Yield equals MBVB. This only works if you have a 1-to-1 ratio, which this one has. Okay? But I'm going to show you how to do it using stoichiometry so that when it's not a 1-to-1 ratio, you've got your tools. Okay? All right, so here, what I know is that I have 12.25 milliliters and it's 0.1 molar. Can't I take molarity times volume and get my number of moles? Okay. And I'm actually going to use my little millimole trick. So what is 12.25, don't use a calculator, times 0.1? 1.225 millimoles. Okay? That's how many millimoles we have of our sodium hydroxide. Now we're going to use stoichiometry. Every 1 millimole of sodium hydroxide, the molar ratio is going to be the same whether you use millimoles or moles, will need will neutralize 1 millimole of HCl. So this seems like a pointless step because it's 1-to-1,
Yeah.
but if it had been 2-to-1, this is where you put that 2 in. So here we end up having 1.225 millimoles of HCl. Now we're ready to get our final molarity. So all we do is we put our millimoles, 1.225 millimoles of our HCl over our milliliters of HCl. What is, no calculator, what's 1.225 divided by 10? If you're dividing by 10, is it going to get bigger or smaller? It's going to get smaller, so rethink. 0.1225 molar HCl. And let's go back and see if that's reasonable. We had 12 milliliters and 10 milliliters. We had 0.1 molar. Doesn't it make sense that it would be very close? 0.1225
Yeah,
molar.
it does make
And that's
sense.
the answer to your problem.
Awesome.